Hi friends, welcome back. Now let us try to find a solution for the priority inversion problem we had seen in the previous session. Here we have two popular methods to combat this unbounded popular priority inversion problem. One is called the priority ceiling protocol and the other one is the priority inheritance protocol. So let's start with our priority ceiling protocol. In the priority ceiling protocol, what happens is whenever a low priority task gets a chance to run, which means that when the low priority task wanted to run, that time no higher priority processes were ready to run, therefore the low priority process starts its execution. As long as it is executing in its non-critical section, there won't be any problem. It will be working in the low priority, and during the non-critical section execution, in any high priority process comes in, then this low priority process will be preempted and high priority process will be given a chance. That's a normal way of working. So therefore as long as the low priority process is working in its non-critical section, it will be working in its low priority mode only. But the moment the low priority process enters into its critical section, that means it locks some resource which is shared. Then, as we have seen in the previous case, then after locking a resource, if any high priority process comes to run the process, then this low level one will be preempted and high priority one will be given chance, and that was creating this priority inversion problem and all that. So in order not to have such a thing, what we can do now is the moment the low priority process enters into the critical section, we can elevate the priority of the process which is currently executing in critical section to the highest priority level. So though the original priority of the process was low, but the moment it enters into the critical section, the priority of that process is elevated to the highest possible level, and therefore from that instant onwards the process with the low priority starts its execution in the critical section at the higher priority, and this will ensure that it won't have any problem of priority inversion, because the current execution of this critical section is being done at highest priority only, and on the way if some process of higher priority comes on demanding for its execution, then it has to wait till that process completes its task, because now the critical section of low level task is being run at a high priority. Therefore the new process which comes in is also having the same priority, and hence doesn't allow for preemption, and hence this low priority critical section will be working intact and will not be disturbed by the high priority, so-called high priority process, because the currently low priority process critical section is run at a elevated level, that's a highest possible priority level at a given time. That means if we know in advance that somewhere in future priority 3 is going to come up, then instead of running this critical section of priority 1 process at priority 1, we can elevate it to priority 3 and start executing. And because of this, what happens is when the priority 3 process comes in, then it is not going to disturb the critical section of this, and will be allowed to complete its critical section, and the moment the critical section is completed, then the resource which was logged here gets released. So then we can start our high level process, and that high level process wants to enter the critical section which was supposed to use the same resource. In the previous example, this resource was held up, and that process holding it was preempted, and hence we had a problem. But now there is no preemption of this process which was holding that resource earlier, and hence it will complete its job and release the log, opens the log, release the resource for others to use. Therefore now the task H can comfortably enter into its critical section. But on the way somewhere the medium uh, priority task might have come up, but as long as this high priority task is running, the medium priority task may not be taken up. But the preemption and all can be made possible only when the high priority process is working in non-critical section. But as long as it is working in the critical section, it will be working at the highest priority, and hence there is no chance of preemption and all that. And that way what happens is we start our low level or low priority task. The moment it enters critical section, the priority of that process is elevated to 3, and because of that it starts executing in its critical section. And meanwhile somewhere while the critical section of task L is being executed, the task H may come up, but because these two are having same priority, therefore task H will not be given chance by preempting it, and hence the task L will continue, and till its completion of the critical section, task L will continue. And the moment task L's critical section is over, then task L's priority is reduced down to 1. Therefore no more part of the task L continues. Then task H continues its non-critical section and then gets into critical section. Then completing the critical section, it can continue operation in the non-critical section, and there can be preempted on the way. And task M may be given some chance for some time, because both of them are not using any shared resources, and hence there won't be any priority inversion problems. Therefore this can be taken up. And then the low priority task cannot continue its execution of non-critical part unless the higher priority processes complete their task. So at the end, after H and M processes complete there, then L will continue and complete its task. So in all, what is happening is, whenever a low level process, low priority process wants to enter the critical section, automatically the priority of that process will be elevated to the higher possible level, so that it will not be preempted by any other process on the way, so that it will be given full chance to complete its critical section run in one shot, so that without any hindrance it will complete the execution of the critical section, and hence releases the resource it has logged, and thereby will not create any chance of higher priority process to keep waiting for this resource which was held for a lower held by the lower priority process. So there is no chance of a high priority process waiting for low priority process to complete its job, and hence this way we can uh, avoid the priority inversion problem. So that's one solution for the priority inversion problem. There's another process called the priority inheritance problem. here what happens is the task begins its execution. So whenever it is allowed, it will start its execution. So as long as no high priority processes are available, then low priority process can continue its working. So it works, it starts its execution, and this part of the execution is a non-critical section. But the here it has entered into the critical section, and at this instant, if the process of higher priority has come in, then what happens is it starts its execution, because this is still a non-critical section of the higher priority task. Therefore it can continue without any problem. But the moment it wants to enter the critical section, then it cannot enter the critical section, because it needs the resource which was locked by this low task process. So the high task process wants the resource, and it looks for it, and it finds that whatever resource it is trying to use is already blocked by lower lower priority task. Therefore automatically, to ensure that there won't be any longer block for the high priority things, so the priority of this low level critical section is elevated to the priority level of the high level process. So it was 3. So we started with low level with a priority of 1, non-critical section execution. Then it entered the critical section. After some time of the process of L being in critical section, the another process came up with priority 3, but it is still in the non-critical section, because it is not demanding any shared resource, so it continues to execute. And the moment it wants to use a shared resource, and that shared resource was found to be locked by a lower level process, then that lower level process critical section is forcibly elevated to the level of this high level, and because of that the preemption is not possible, and hence critical section of task L is allowed to continue. And once the critical section of task L is over, it will release the lock, and that lock is acquired by the task H, and then it can enter its critical section. And after critical section of H is over, then it continues its non-critical section. On the way somewhere medium level has come in. Then what has happened is, at this instant, the here we have a task working at priority 3. Then here we had a critical section of priority 1, but because of requirement of the resource by priority 3 task, this priority is elevated to 3, and the task L is allowed to complete, and then task H gets into its critical section. So till then the task M has to wait. So in this, if you just look at it, whichever is executing, it is always at the higher level. So we can avoid the priority inversion problem whether through inheritance, where the critical section of a low priority process is its priority is elevated to the highest possible thing, so that it doesn't get preempted and it completes its task. Only when the high priority process comes into existence and wants that resource which was held up by the low priority. So if the task H did not ask the resource at this instant, then this would have continued working with and then that would have started there. So that's what we are talking all about here in the sealing process. The moment the low priority process wants to get into critical section, then it is executed totally in the high priority level. But in this, it continues to execute in the low priority unless until the high priority process comes to run. Until then it will continue at the low level only, and when a high level comes in, then preempted and high level non-critical thing starts working. And when the high level thing wants to enter critical section, which is not possible, realize that till this low level priority critical section is solved, we cannot continue into the critical section of high priority task. Therefore, elevate this to high priority and complete this task and then take up this one. So that is another way of solving this problem. So if you find these things of any help, please do like, share, comment, and please subscribe to this channel. Thank you.